Hello students, welcome to EPG Pathshala. I am Dr. Hemant Sharma from MIT University Gurgaon. Today we are going to talk on module regression analysis, an introduction to model building under the paper quantitative techniques for management decisions. In this module, we will try to touch various topics and you would be able to understand the basics of the concept of the simple regression, how to develop a simple linear regression model, how to fit regression equations, and understanding the assumptions of simple linear regression model, and finally, how to check significance of regression coefficients using t-test, and finally, how to test the goodness of fit of the proposed simple regression model. The students, the term regression, it means basically moving backward or returning to the average value of the variable. Here I must tell you that regression comes after the correlation. In correlation, what we did, we tried to understand the relationship between the two variables, and in regression analysis, now we will try to make the use of that knowledge. After having established an association, a relationship between the two variables, now in regression analysis, we can also find out the nature of the relationship, by using which we can predict the unknown value of one variable for the given value of the another variable. This is the main purpose of the regression analysis. There are many examples by which you can understand the significance of the regression analysis in the different business organizations and the different economies. A government is always interested to know or to predict the the production of wheat in next 2 years if the amount of rainfall is given. So this prediction is very important because by estimating the future value of any variable, government can draft its policies, and government can allocate the budget to the different sectors of the economies in view of this prediction. So it is necessary that government or business managers are able to make correct predictions, accurate predictions. So simple regression analysis makes them able to make the accurate prediction of the variables of their interest. In simple regression analysis, we are considering only two variables. One is dependent variable and one is independent variable. And for the unknown value of the for the given value of the independent variable, we will try to find out the unknown value of the dependent variable. Now we can also understand the utility of simple regression analysis by the example of the banks. Banks are always interested in knowing the demand of the various types of the loans and the various types of the governmental policies, so that they can adjust their interest rates, their prime lending rate, their CRR accordingly. So regression analysis, no doubt, it is a very good technique to tackle with the uncertainties to be met in future. Here it is important to tell that regression analysis also assumes a linear relationship between the variables, as in case of the Pearson's coefficient of correlation. But as far as the term dependent and independent variables are concerned, these are purely mathematical relationship. Their explanation can be made only by a proper covariance analysis. Regression analysis again doesn't speak about the cause and effect relationship. As I have already discussed that regression analysis is mainly used to find out the unknown value of one variable with the help of the given value of the another variable. So in this present dynamic world, it has been become a great challenge to survive, and therefore every organization has to make prediction of the future events. And if these predictions are accurate, we can take the right decisions for the future in this uncertain world. So it depends upon our prediction capability. Now we will try to develop a model that will help us to make good future predictions. Now in this slide you can see that we have some data set, and this data set is used in a statistical model, and finally we have a result, and this result is comprising of mainly two portions, two components. First is systemic component and second is random component. Here we can understand that systemic component is that component which gives us the correct prediction for the given data set, and random component is that which is firstly occurring purely random basis, and the source of which is absolutely unknown, and therefore it cannot be predicted by the model. So now we will try to develop a regression model that can help us in making the predictions, and we also want to keep the random component, that is also known as error or residual of prediction, at the minimum level. So in this regression model we will propose, the proposed regression model is mentioned in this slide as y cap is equal to alpha plus beta x plus alpha. So here y cap is the predicted value of the dependent variable, x is the independent variable, that is also known as the predictor, alpha is the prediction error, and beta is the slope of the estimation line. In this equation we can see the right portion alpha plus beta x plus alpha. This portion is known as the estimator. That can be any rule or any formula or any algorithm that is used to predict the value of the dependent variable. And here alpha, beta are the unknown constants which we need to calculate to predict the value of the y. And here it is interesting to see that it is only the error in this equation that makes this model a probabilistic model, because alpha plus beta x is the fixed component, and for any value of x we can easily predict the value of y with the full accuracy, full confidence. It is only the alpha term that is making this model a probabilistic model. Now, what is a good estimator? So, obviously, the computational cost of our estimator must be minimum, or we can say less, or highest R square coefficient of determination, and it must be a linear estimator, and it should be purely unbiased estimator, no personal biasness should be there, and minimum variance of the efficient estimator, and it must consider the full information of the data set. Components of the proposed model. In the proposed model, we can see there are two main components, systemic component and random component. So systemic component is shown by a very clear mathematical relationship alpha plus beta x, and which can be calculated with the certainty, and alpha is the random component, the source of which is not known and it cannot be estimated by the our proposed model, regression model. So as we have developed the simple regression equation to predict the value of the variable y for the given value of the variable x. So y cap is equal to alpha plus beta x plus alpha error term, equation number 1. So in this equation, error term is the alpha, and this term is making this proposed model a probabilistic model, because as the value of alpha, value of error will increase, the predicted value of y will also be affected. If the value of error will decrease, again it is going to affect the value of the dependent variable y. Now here it is important that systemic component of the given systemic component is equal to the alpha plus beta x. That is a very well defined mathematical model, and for this model value of y can be predicted very easily. Now random component is the error in this model, and we are not knowing the source of this error, so it cannot be predicted by our model, and efficacy of our model is depending upon this error term. If the error is less, in that case prediction would be more effective. If error term is the larger, then effectiveness of our model will automatically decrease. So we always try to keep this error term at the minimum. And one more important observation here, that actual value of the variable is equal to the average value of dependent variable for all given values of x plus the error term. So it is also visible in the graph shown on the next slide. In this graph we can see the estimation line and error of estimation and estimated value of y, that is equal to a plus bx, and these are the different points which are scattered around the estimation. Now we will try to estimate the parameters of our proposed models. So there are two parameters, alpha and beta, so obviously we need to have two equations to calculate these two parameters. Now here we will be using the method of least square to find out the value of alpha and beta. Here it is important to note that least square method is a method that is calculating the values of alpha and beta in such a way that the error of prediction is at the minimum level. This method is also considered as best linear unbiased estimator, that is known as BLUE, that gives both unbiased estimators. Best fitted regression line would be y is equal to a plus bx and x is equal to a plus by, when x is the dependent variable. So for two unknowns we need to have two normal equations, and method of least square suggests the following two equations to calculate the value of a and b. By solving both the equations we can easily calculate the value of a and b as shown here. So a is equal to y bar minus b x bar, and b is equal to sigma xy minus n x bar y bar upon sigma x square minus n x bar square. Now we also need to calculate the significance of the parameters in our model. So here we have calculated the A and B. Here A is equal to the alpha in our population model and B is corresponding to the beta in our population model. So before using the values of A and B in our model, first it is necessary to find out the significance of these parameters, how significant these parameters are. So for this we can use the t-test. Here we see that these values of A and B are significantly different from the 0. So once we calculate the value of t using the t-test and its value is found to be significant, in that case we will assume that there is parameter is significant and it must be retained in the equation. And as far as the range of this parameter is concerned, it can also be calculated using the formula a plus minus standard error of t-test, and similarly we can find out the significance of the beta, that is equal to the b and the range of the b. Now we want to check the simple regression equation which we have developed as previously. So here we assume that we have calculated the values of all parameters alpha beta of the proposed equation. Now we want to see the goodness of fit of our regression line. So it can be ensured by viewing the sum of the error. If sum of error is equal to 0, so this means that this is the best possible regression line to give the estimated value of y for given value of the x. Now we can also check it out by taking the sum of the square of the errors, and it should be equal to the minimum. It should be equal to the minimum. That is the property of the least square method. As we know that least square method predicts the value of dependent variable in such a way that error scattered on both the sides of the regression equation is equal to the minimum. Now standard error of estimation is again very important parameter of the appropriateness of the suggested regression model. Here mean square error is an unbiased estimator of the variance of the population error that is denoted by the sigma square. So mean square error, it is equal to the sum of square of the error divided by the degree of freedom. So here n is equal to total observations, k is equal to number of independent variables, and we can calculate the standard error of estimate using the formula standard error is equal to the under root mean square error. It is very important parameter which shows the worthiness of the suggested regression model. We can also calculate the standard error using this different formula sigma under root sigma y square minus a sigma y minus b sigma x into y divided by n minus 2. So this formula can also be used finding out the approximate interval. If we assume that all errors of prediction are normally distributed around the estimation line, in that case we can also find out their intervals as is shown in this slide. So first interval we can see the range is y is equal to a plus bx plus minus 1 standard error. For the second range it is corresponding to plus minus 2 standard error. Third range is corresponding to the 3 standard error. So if errors are normally distributed around the regression line, we can say that 67.37% errors observations would be in plus minus 1 standard error range, and 95.45% observations would be in plus minus 2 standard error range, and similarly 99.73% data points would be in plus minus 3 sigma standard error range. Here it is important to note again two important assumptions: that the observed value for y, observed value means actual value of y, is normally distributed around each estimated value of the y, and second, dispersion of distribution around each estimated value is the same. Obviously, if the second assumption is not true, in that case standard error at one point of line could differ from the standard error at another point. It should not be there. Now we attempt to test the goodness of fit of the proposed regression model. Now to see the goodness of fit of the proposed simple regression model, there are different parameters which we can check out, like coefficient of determination, undoubtedly the most significant parameter to see the significance of our proposed model. So as the value of r square goes up, the significance of our model also increases. So it is directly proportional to the significance of our model. So ideally it must be uh, above 60%. In some cases a little lesser value like 58%, 59%, that is also acceptable, but the value of r square should be as much as possible for the good significance of the proposed model. F-test, it measures the overall significance of the model, and it is a very good test that is measuring the linear relationship between the dependent variable and the independent variable. So F-test, it is inbuilt in the ANOVA table, that is a byproduct of the simple regression analysis. Whenever we try to run the simple regression analysis using any software, this is an essential part of the output. So in ANOVA table we can have the direct value of the F ratio, and if it is significant, it means the linear relationship between the dependent and independent variable is also significant. It means our overall goodness of the model is good. Next is the testing the significance of the parameters of the model individually using the t-test. So we have already calculated the various parameters of the model like alpha, beta. Now we can check out the significance of these parameters using the t-test. So here we assume that their value is equal to 0, and we take the alternative assumption, that is their value is not equal to the 0. It is significantly different from the 0. So using the t-test we find out the t-statistics, and if t-statistics is found to be significant, it means we will be assuming that value of parameter is significantly different from the 0. So again, it is very important to check out the significance of the parameters, because the decision pertaining to retain them in the equation or exclude them from the equation, it depends upon their significance. Now residual analysis, it is again very important technique to see the worth or the significance of the proposed model. With the help of the residual analysis, we try to see that we have made the different assumptions of the regression model. Now all assumptions of the regression model will be discussed in the next module, multiple regression. Standard error of the estimation, again it is very important parameter to see the worth of the proposed model. If standard error of estimation is lesser, it means our model is more useful or more worthy to make the prediction. So we always try to keep this standard error at the minimum, and it is usually and it's equal to the under root mean square error. Residual analysis, that is very important analysis to find out the significance of our proposed model. Now we will learn this residual analysis in our next module in multiple regression. So using above information, we can check the sum of the individual errors also in our case, and if it is equal to 0, it implies that we have not committed any serious mathematical mistake. Otherwise, we need to go for any other model, or we need to bring another sample in our study. And it is also obvious from the previous discussion that the more the error of estimate, the greater the dispersion of data points around the estimation line. It means if errors are highly scattered around the estimation line, it means our prediction strength of the model is lesser, and lesser the scatteredness of the data points around the estimation line, it means more accurate and more capable prediction capability of our regression model. So ideally, in the ideal case, the sum of errors should be equal to 0. Now if it is not equal to 0, it should be least possible. So now we can summarize what we have learned in this model simple regression analysis. No doubt regression analysis is a very important technique to find out or to estimate the value of one variable for the given value of the other variable. And in simple regression analysis, there is one dependent and there is one independent variable. The variable whose value is to be estimated is called as the dependent variable, and whose value is given, that is the independent variable. The important thing about the regression analysis that this is signifying an average relationship between the two variables, and it assumes a linear relationship between the variables and is expressed as a straight line equation. To test the goodness of our proposed model, we may have different parameters as already discussed in scatter plot. We can go for the scatter plot, we can calculate coefficient of determination, we can calculate the significance of the parameters of alpha and beta or A and B, and we can also find out the F statistics, or we can go for the residual analysis. These all are the important parameters to be checked to see the worth of our proposed model.